Welcome, imaginary friends. Have ever wanted to time travel into the past? Well, you might be able to. But even if not, you can still travel into the future, just as you are now. According to Einstein's theory of special relativity, particles with a positive non-zero mass cannot travel faster than or at the speed of light. However, if we have somehow a particle that starts faster than the speed of light, it cannot travel slower than the speed of light. This brings us to tachyons. Tachyons are particles by definition with imaginary mass. One of Einstein's relativistic equations suggests that tachyons travel faster than the speed of light. Another one of his equations suggests that the perception of time for tachyons is reversed. This implies that causality is violated, which means that cause and effect can be swapped. So, when you take a test, you can fail before taking it. That clearly happens. We always get F minuses. So tachyons must exist. Well, that actually doesn't count as proof for tachyons. String theory views tachyons quite differently compared to relativity. String theory is about guts and toes, and how they can never be separated. Yeah, that's not string theory. String theory is a grand unified theory, or theory of everything, or also known as gut or toe. String theory actually suggests the existence of tachyons, which makes it quite interesting. To see what tachyons imply in string theory, we begin by plotting a quadratic potential energy nearly representing a spring or oscillator for real mass m. According to this equation, the corresponding motion will mimic gravity with no friction. Therefore, if we start at some arbitrary point like this, it will just roll back and forth, representing oscillations. This graph is concave up because it's stable and therefore happy. Now, if the mass is imaginary, then by definition the mass squared will be negative, flipping this graph upside down. Placing the starting point at the origin will do nothing, since it's just able to balance there. When we shove this point a little bit, yeah, that's not good. Instead of oscillating back and forth, the object or particle will just move away from its starting point exponentially quickly. This violates the conservation of energy, as it keeps speeding up, thereby increasing the total energy of the system. You may call this graph concave down because it's unstable and therefore sad. Now, the actual potential looks like this. Beginning at either of these unstable points will lead to either utter disaster or just peaceful oscillation. Remember, this is potential energy. Therefore, this particular stable point represents a universe that disappears as it's zero there. Research shows that tachyons may still play an important role in string theory, as they comprise most universes. Even though there may exist unhappy potentials, most are fully content. Wait, you're still here? Well, so there's still much unknown about tachyons in string theory, but if we somehow ever prove their existence, then we may be able to time travel into the past and rewatch this video.